Hey there guys, today we are gonna go over the Simple Token Wallet from the Monad Developers Community Monthly Coding Challenge. This challenge requires us to design and develop a simple token wallet, and here are some of the objectives and key requirements. We need to create a token wallet contract using Scaffold.eth. We need to implement the deposit functionality, a withdrawal mechanism, the ability to track individual token balances, all while implementing some basic security measures and having comprehensive event logging. The README further mentions some evaluation criteria, setup instructions for scaffolded and the recommended approach. And going into the repo here, we have a Next.js folder to develop the front end for the challenge and a Foundry section for putting a smart contracts in. But since the challenge does not require us to necessarily develop a front end, I'm going to go with my own Foundry setup, which I have opened here in VS Code. We have the GitHub folder with a test workflow, which just builds the project and runs some tests on each push. We have the .vs Code folder recommending some extensions for this challenge. A broadcast folder for tracking previous deployments, a lib folder which holds the external extensions or the external libraries that we're going to use for this challenge. We're going to just use Open Zeppelin contracts for EIP 712 structure signatures as well as handling the ownership of the wallet. A script section to just have a script for deploying on any network, on any EVM network. And then finally, we have the source folder, which holds our smart contracts, and a test folder, which holds some helpers and a singular test contract. So let's jump straight into the wallet. As we can see, we are using Solidity version 0.8.24. We are importing a bunch of interfaces and extensions from Open Zeppelin. We have the IRC20 interface and ownable extension to manage ownership of the wallet, SafeERC for safe token transfers, ECDSA and EIP712 to enable gasless transfers, which we're going to discuss later on. And we also have the IW native. This basically stands for an interface for the wrapped native token, which in the case of the mainnet would be the wrapped ether contract. Now coming to the contract, since we're going to support EIP 712 signatures, we have the struct type hash. This struct will allow us to send an intent to the contract, which will enable anyone to pay for the gas fees and conduct transfers, approvals, withdrawals, etc. We are setting the wrap native token as an immutable variable here, the nonce to prevent replay attacks for our signatures. Now coming to the constructor, it's very straightforward. We are going to initialize the owner of the contract so that anyone can deploy a token wallet for any other user, even if they don't have the gas. We're going to initialize the EIP712 related metadata, which includes the name of the contract and the version. Further, we are going to just check if the paths and addresses are 0 or not, and then initialize the wrap native token address. We have the receive function here, which allows anyone to send the native gas token to this contract, and it will immediately be wrapped into the wrap native token. This is to ensure that we do not have to write additional functions that handle the native token transfers. We can just use ERC20 functions to even handle the native tokens, and it just reduces contract deployment size and a lot of cuts out a lot of the complexity. We have the deposit function, which just takes tokens from the message.sender, the caller, and deposits it into the wallet. This is more sort of a utility function because you gotta first approve the token to the wallet and then call this function. So a two-step deposit isn't what we like, but since it was mentioned in the uh, challenge as a key requirement, it's just here for utility purposes. And it's not guarded by an only owner modifier, so anyone can come in and deposit any token into the contract. The withdraw function is an only owner function which allows the owner to withdraw any token from this contract. The transfer tokens function allows the owner to transfer tokens out from this contract to any other address. The transfer tokens from allows the owner of the contract to use the allowance of tokens provided to this contract. Now we have the approve function. So this function allows the owner to provide a token allowance to any other address. As you can see, these functions we have gone over uh, are guarded by the only owner modifier. So it requires the owner to have some native gas tokens to pay for gas and call these functions. To avoid that, we also have, to avoid paying gas or allowing for gas sponsorship, we also have functions that use EIP 712 structured signatures. And basically, a user can sign an intent for a transfer or an approval and just ask someone else to pay for the gas, basically play the role of a relayer and call these functions. The first function we deal with is the withdrawal signature, which allows anyone to pay for the gas and withdraw tokens from this contract. We first check the signature, the nonce, and then the deadline. The nonce is important because it prevents replay attacks, so the same signature cannot be used twice to withdraw tokens from this contract, the deadline to ensure that the signature is not valid infinitely, and then we transfer the tokens out to the message sender. Continuing forward, we have the transfer tokens with signature, which allows anyone to pay for the gas and transfer tokens to any arbitrary address as mentioned in the signature. We have the transfer tokens from, which allows anyone to pay for the gas and use the token allowance provided to this wallet. We also have the approve with signature, which allows anyone to again pay for the gas and provide an approval for tokens to any other address. Now we're going to go over the internal functions which were used above. We have the transfer tokens function, which just checks if the input parameters are correct. Just do a sanity check for address 0 and amount 0, and check if the the wallet actually has some enough balance for the transfer. Conduct the transfer using safe transfer and emit the event. You have the transfer tokens from, which basically does some sanity checks if the allowance for the contract is enough, and then does a safe transfer from, emits an event. Similarly, we have the approve function, which again does some internal checks, so sanity checks, and then approves the amount and emits an event. Now, coming to the check signature function, this is crucial. It is crucial to develop this correctly. We have the from parameter, which determines the address we are going to subtract the tokens from, take the tokens from. The recipient of the tokens, the amount of tokens is approval. This is mainly for security purposes, because if we allow approvals to be done using the same four parameters mentioned here, someone could not approve the contract, could not like call the approve function and instead transfer the tokens out. So this method basically prevents against those attacks. We have the nonce and the deadline and the signature. We use the ECDSA library to recover the owner of the uh, this wallet and whether they sign the signature or not. And if we report if the signature is invalid, that the owner extracted from the signature is not equal to the current owner. For nonce checking, it's pretty simple. We check if the nonce passed in the signature. is equal to the current nonce plus one, and then we increment the signature, indicating uh, that the same signature cannot be used again. We check the deadline and revert if the deadline is passed. And here are some view functions to uh, utility view functions to just get stop from the storage slots, like getting the wrap native token, getting the next nonce to be used for signatures, getting the token balance of any tokens. This is crucial because the challenge specified that we need to track token balances, individual token balances. So tracking them in arrays in sorry in mapping is not very gas efficient, and there could also be a disparity in the actual tokens held by the contract and the token balances stored in the mapping. So they just fetch the token balances dynamically, reducing gas and storage costs. We check the allowance for a given token provided to this wallet, and this is a utility function which can be used off-chain to build the signatures for any kind of transfer approval. We also have this contract as ownable, which basically allows us to transfer ownership of the contract and provides us with the only owner modifier. That's pretty cool, I believe. So I guess that's all about my submission for this challenge. I believe I've covered all the key requirements and also added a couple of bells and whistles with ownership management of the wallet and EIP 712 structured signatures supporting gasless transfers. And you can find this repo link down in the uh, description, and you can just play around with it. I've also built a nice test suite that you can check out, testing all the functions from different angles. Uh, yeah, just go around and play with it. And thank you for watching. See you next time.